Right, hi and welcome to this short video about my little project called the HC800. This is my vision of a home computer that might have been in the late 80s. I've been using the Amiga 65 to do development lately. Before that I've been using the Spectrum Next, which is also a fun platform, but the Amiga 65 is great for this project. Also, being a Commodore boy, it's a lot of fun to work with. But let's have a quick look. Right, slot 7. There we go. Okay, so now when it starts up, it'll start by checking the UART host. When I do development or write software for it, I have a small file server that runs over the debug port, so I don't have to copy things over to the SD card all the time. It's also handy for kernel development. I can use or load a new kernel over UART instead of using the built-in one. But we will just use the built-in one right now. So this is the boot up screen. So there's only a megabyte available on the Amiga 65 right now, at least, because that's what's the amount of block RAM I can use. There's a ready prompt, of course, and this is the current path, the current directory. We can type dir to see what's on this. This is the Amiga 65 SD card. We can see what devices we have. There's SDA, which is the card at the back, and SDB is the internal one. There's nothing mounted there at the moment, or actually there's a small SD card that the core cannot read yet. SD cards are annoying. You can see which volumes are mounted, and yeah, we have the V0 and the V1, which is the UART file system. The kernel is, I wouldn't say complete, but it's getting there, and we have a device abstraction and a file system abstraction and that kind of thing. You can see what do we have on the UART file system. Yeah, we have some of the test programs that I use to test things with. Also, you can see the volumes and the dir command there. There's another one called ASCII, which just prints out the ASCII table, or rather the Windows 1252 code page that I use. We can see if we want the code for the ASCII program. Yeah, this is very impressive. I think you'll agree. The UART file system is not very fast, and this program, the type program, just loads 1 byte at a time over UART and then prints 1 byte at a time. So it takes a little while to print out the source code. But it's pretty small. It's just a small little program. This is what some assembly on the processor looks like. This is a completely custom processor. It's an architecture I've been developing for a number of years, actually, and trying different things and trying to strike a balance of something that's fun to use and still simple. One of the goals is one opcode is 1 byte, and it should be fun to work with still. Right. So I don't think there's a lot left to see. What do we have? No, we have the graphics demo, of course. There isn't a lot of hardware yet in the machine. There's all the stuff that makes it tick, like an interrupt controller and an MMU and things like that, and a bus arbitration system and all that kind of stuff. So there is only a text mode screen at the moment, which is what we're looking at, of course. It has a few fun features like underlining text and bold facing text and italic or oblique, really, which is a little unusual, I guess, but also fun. So yeah, we have this small graphics demo. Oh, sorry, that's on the UART. And this is, yeah, it has soft scroll as well. Like a console, it's a wrapping text mode, so it's pretty fast to scroll and plot new tiles and stuff like that. And there's a vertical raster interrupt here that's used to plot the color bars. I don't think there's a lot more to show. This is what it can do at the moment. I don't know when there'll be a release. I guess it'll have to be when the SD cards are working reliably and the FAT32 implementation is stable, so you can actually also save stuff, that kind of thing. So it's probably, yeah, it'll happen at some point, but there's no deadline or roadmap or anything like that. It's just a fun project I'm working on from time to time. So that's it. I hope you enjoyed a little sneak peek. Bye.